Hello everyone, welcome back to CodeLabs 2018 Summer. Really glad to have you with us today. Today we are going to be doing something really cool. We are going to be making a video game from scratch in Unity. And the idea behind this is that this workshop is for people who maybe have never made a game before, or if they have, maybe it was in a really basic introductory workshop, such as the one that we teach at Code Day and Construct. And that is great and fun, and it's really great to have people making games in whatever language they want. But let's say that you want to do something a little bit more complicated, or maybe you want to make something that is sort of a production ready, as I call it, production ready game, or whatever else. If you want to make any sort of game, Unity is a really popular tool for doing so. It's been used by a lot of really professional companies that are actually making professional games. You can make games in Unity and release them for most major consoles, including like the Nintendo Switch. You can make VR games, you can make web games, you can make desktop games. A significant number of games that you'll find on Steam, even ones that are very well respected, are often made in Unity. So Unity is a really, really great platform that's used both by beginners and professional developers alike. And you can make 2D games, 3D games. I have even seen people make 4D games in Unity. So today we're going to go through just sort of the really basics of making a game in Unity and hopefully give you a starting point. The goal is not necessarily to teach you everything there is about Unity, because like anything else in programming, that's pretty much impossible. But our goal today is to cover the very, very basics, the minimum that you would need to know, just to sort of get started and know what to Google when you're actually trying to make a professional game. As always, if you have any questions throughout the entire workshop, post them in the chat. I have it open in front of me, which is why I sometimes glance down rather than looking at the camera, that or looking at my laptop. If you have not yet, it is very, very important that you download and install Unity, and you're probably going to miss about half of this workshop because it is a fairly big download, but you can always go back there. The VODs for this will be on our YouTube channel as well as on our Twitch channel for as long as it will let us keep them there, and they'll be on our YouTube channel indefinitely. So go ahead and start downloading Unity now in any case, because it is a pretty big download. Unity, by the way, runs on Mac, Windows, or Linux, but the Linux one is a little bit more difficult to get started, and you'll probably see me struggling with a few bugs that it has today. So we're going to go ahead and get started. Switch over to our split screen. One other problem with Unity is that it is a little bit, it's one of those programs where you can't change the font size. So I'm actually going to go ahead and just switch to just showing you the screen so you can see a little bit better what we're doing, and hopefully that's okay. If you're having any problems, maybe pull it into a full screen. So we're going to go ahead and create a new project. If you have not opened Unity before you do this, you will need to sign into an account. Accounts are free. Accounts are totally free, but you do need to make an account, and you can just say that you're a hobbyist or a student, and they won't charge you anything. If you choose that you're a professional, they will charge you something, but this is for your own use, hopefully, so you're a hobbyist. So we're going to go ahead and we've already logged in on my account, so I'm just going to go ahead and create a new one. I'm going to call it CodeLabs 2018. I'm just creating it in my folder where I store Git repositories. My organization is myself. I'm going to choose 2D instead of 3D. You can see that there's a bunch of ones. You got VR or whatever else. I want 2D because we're going to make a 2D game. 3D games are dramatically more complicated, as you will find out. And if you're not really, really into math, I would recommend avoiding 3D games, at least for a little while, because it does get a little bit more complicated with some of the math needed for things like rotations. So we can enable or disable Unity Analytics, doesn't matter, I will leave it. We're not going to add any assets, so we're going to go ahead and create the project. And Unity is going to do some weird things with my screen because of the fact that I have Linux and i3, and it's going to sort of jump around and do a bunch of weird stuff. So we'll give it a few seconds. While we're doing that, maybe we can talk just a little bit about what sort of game we're going to be making. So my goal for today is to just build a really simple platformer. It should look decent, shouldn't be super beautiful or anything like that. We're not going for absolute polish. Simple platformer, you can jump, you can run, and we get some collisions and some things like that. That is all we're going to be working on today. We're not going to make the art ourselves. We will find some art so that we don't have to do anything too complicated. Now, Unity is going to take a few minutes to load on my computer just because it is a little bit slow and Linux support is not necessarily great. So we'll wait for that to happen. And hopefully all of you are getting in a little bit faster. Someone was asking just now in the chat, can the links for the art be sent here? We're actually going to go ahead and find some of our own art. So while we're waiting for my Unity to load, because it is taking a little bit longer than I remember before, and there's a chance I'll have to restart it or something, we can actually start getting to work on some of the art stuff. So I'm just going to talk about briefly what is art in video games. So if we're building a platformer, we have two different types of things that we're going to need to make, right? We have the platform itself, and there could be multiples of these, right? So we have the platform ourselves, and then we've got our game object, right? So this is like our player character, and I'm just going to draw this as a block with a face. If any of you have played the really great game, actually, Thomas Was Alone, that actually might be somewhat familiar to you, because that is what it looks like. And I think Unity has crashed. I'm going to go ahead and restart it. And we'll try that again and see if it works. So we actually have two different things here, right? We have the platform and we have the character. And so those are the two objects that we're going to be making. We're actually going to need to find art for both of those objects, which is something that we can do. And what we'll be looking for is we'll be looking for two pieces of art. We'll be looking for obviously the character itself, and then the second thing we'll be looking for is just a repeating background for the platforms. And it'll be repeating just to make it a little bit easier for us. But if you were making this yourself, you could be making it, as easy or as complicated as you want it to be. And I'm still not sure what's going on with Unity, so we're going to go ahead and quit again. I did test this right before we went live, and I guess I should have just left the project open. Let's try opening my other demo project and see if that fares any better. Okay, so we're just going to go ahead and we'll just delete all of this. I don't know what was going on with that, but Unity has some problems. So we'll go ahead and delete all of this and put it back to exactly where it would be in a brand new game. Delete all of that too. Okay, so we're back to at least a brand new game, for whatever reason having some problems with Unity. So we are going to need some objects. What I'm going to use for the art for those objects that I was just talking about is this website called Open Game Art. Open Game Art is great, it's wonderful, and it's basically a resource for free game art. And I think actually the original sound pack that was used in Minecraft was entirely from Open Game Art, if I'm remembering quickly. It was not the one that was in the release game, but all the betas for several years were using free sounds from Open Game Art, which is cool. So it is very professional looking art. Before we get into the art, we're going to need to actually make something. We'll go back to just showing the screen only. So we got a few different parts of the editor up here. We got this part over here, which is, we're going to talk about that in a little bit, but this is sort of a list of our objects. I'll make it a little bit smaller. Maybe shouldn't have done that. Okay. Like I said, Unity on Linux is a little bit buggy. So we're going to go ahead and relaunch that and not resize anything ever. And hopefully this time will be better. And this is not looking super promising so far. Yes, there we go. Okay. Don't resize anything. Got it. So we're not going to talk too much about what this left-hand side of the screen is for just yet. We will get to it in a second. This bottom part is where we'll store stuff, files, things like art. And then this right-hand side of the screen is where we'll configure things. So it's where we'll put information about objects, like how fast we want them to go, and things like the speed, or like the collision control and things like that. Right here is our actual map. So this is what our world will look like. There's this button right here that says 2D and 3D. And if you haven't started with a 2D starter project, it's very important that you click this and click on 2D. because if you leave it in 3D mode, it's going to be really complicated to edit your game. Again, not that you can't make a 3D game with Unity, just that it's not recommended for a total beginner. So what you're going to want to do for the start is just go ahead and click this 2D button so that we can start off in a 2D version. And you can see now when I zoom in and out, it zooms in one direction rather than leaving me kind of all over the place. We also got this background. We could change it. Not going to worry about it for right now. So what we're going to do first of all is we need to create an object for our player character, and we need to create an object for the ground. Now, in theory, you could just create them as what we call a sprite. Pretty much everything in a video game is a sprite, and a sprite is, again, more or less, this thing would be a sprite, this thing would be a sprite, this thing would be a sprite. Almost everything in a 2D game is going to be a sprite. But we are actually, rather than creating a sprite directly, which you could do, it's under 2D object sprite, what we're going to do is we're going to create something called an empty. And there's a really good reason for this, which is that things in Unity can actually be nested. And sometimes you'll want to have multiple things associated with a certain object, right? So for example, the player character will have its art, but it'll also have a camera following it around. And one of the nice things about creating an empty is that we can just nest as many things as we want inside of the outer concept of a player object while still being able to do things with the inside part. So we're going to create an empty. And I'm just going to go ahead and rename it. Hopefully this will work. Sometimes I can't type in Unity. Nope, can't type in Unity. If I leave and come back, it'll fix it. Go ahead and rename it player. And we're going to go ahead and create another empty, and we're going to, and you can see this nested by default, so I'm going to drag it up so it's not nested. And go ahead and create this one. I'm going to name it ground. Cool. And, rearrange them, whatever else. So we have our player, we have our ground, and then what is going to be inside of the player? Well, it's going to be a sprite. So what I'm going to do is I'm going to right-click on the player, new 2D object, sprite. It's very important that everything you choose is 2D and not 3D for this first game, because again, like 3D games are way more complicated. So right-click on the player object, new 2D object, sprite. And we can just call it player sprite. Rename it over here or over there. I spelled that wrong because of Dvorak things. Yeah, the way that Unity works with keyboards in Linux is also pretty buggy. We're going to right-click on ground as well. We're going to create a new 2D object. We're going to name it, we're going to create a sprite, and then we're going to call this one ground sprite. Cool. Good. We got our two sprites. There's absolutely nothing here yet. You can see I can actually hit the play button and it will switch over to this little game tab right over here. It'll take a second and there's nothing going on, and that's because we have no art for our sprites yet. So what we're going to do for art is we're going to go to this really great website, opengameart.org. And what we will do is we will just find some platformer art. So let's just search for platformer. We'll search for a platformer, and we'll just look for a character that we like. We can even search for platformer character. Everything on OpenGameArt is free to use. In most cases, you will need to credit the person at some point. So I'm looking for just sort of like a side-scrolling platformer, and I kind of want it to be kind of pixely. So we'll take a look, and we'll see if we can find something good. Yeah, I guess this will work. It's not great. We can also, one thing you can do in Unity is you can do animations, and so sometimes you'll see that as like a series of animated characters where they're like in and out of step. I am not going to use that in this demo, but Unity animation is not super difficult. This is not the world's best looking knight. Let's see. I found something earlier that was pretty good. Our king. I think he was a king. See if we can find something. While I'm doing this, feel free to find something that you like as well. Let's actually, this looks good. I don't know what this thing is, but it's kind of creepy in a weird way. Don't want the looping one. Okay, well this one only has a looping one. I don't know what this is going to do, so I'm not going to pick it. Let's just go back to platformer. I'll just find something really quickly. Let's just pick this bird. This bird is going to be my platformer. Again, while I'm doing this, feel free to pick any platform character that you like. We're going to go ahead and download that. And then we also need platformer. We need a tile. So we'll try tile. See if this comes up. We're looking for just a platform. Pixel art, wood, blocks. This looks okay. We'll go with this. One of the downsides, of course, of open game art is that things do not always look that great. Okay, so we got our art. I'm just going to go ahead and oops. Just going to go ahead and unzip it. 32. Cool. And then the other thing we're going to need to do is we're going to need some of these come on a big sheet, and we're going to actually need to crop them down. So I'm going to go ahead and open my thing. I'm using GIMP. You can use anything you want. Go into downloads. We got this enemies thing. And I'm just going to pick one of these. Pick this bird. And I'm just going to sort of trace an outline around him and just do crop. I think the background is brown here, which ideally I don't want. Okay, transparent layer underneath him, just in case it cares. And then don't know how to select things in GIMP. I don't really use GIMP ever. So this is a learning experience for us both. I'm just going to delete some of this background. This is a lot of games as well as getting the art right. So I'm just going to go ahead and delete some of this. And again, while you're doing that, hopefully this will give you some time to catch up. And again, what we want is our two things. We want our player character, and we want our background, like our platform. Although you could find an actual background as well if you want a background. So I'm sure that there's a better way to do this in GIMP, and someone who has more experience with GIMP could probably tell me, but that's good enough. So we're going to go ahead and save this. And what I'm going to want to do is I'm going to want to find where that Unity project was. So in my case, it's here. It's called CodeLabs Demo. I'm going to want to find the folder where we saved our Unity project. And if you can't remember, you can actually just right-click here and click Open Containing Folder. And it'll show you the location. You can right-click on anything in this lower pane. So I'm going to go ahead and find that. And inside the Assets folder, that's where I'm going to want to save it. So I need to actually export this because I'm using GIMP. So again, I put this here, CodeLabs Demo, Assets folder, and then I'm just going to call this player.png. I'm going to export it. And then the other thing, of course, I need is our blocks. So I'm just going to pick a block that I like. We'll make this well, what do we got? Leaves. We'll just make everything leaves. So we got our block. Again, I'm going to go ahead and export this and save it to my folder where this is all in. Again, the assets folder. I'm just going to call this ground. And we'll go ahead and export. Great. So now when I go back into Unity, you can see these two will actually show up, which is great. We got our sprites. This guy is a lot smaller than I thought he was going to be, but that might be okay. This might look a little bit out of scale, but that's fine. One more thing we need to do. So, so someone was just asking in the Q&A really quickly, what does platformer mean? Platformer just meaning like a guy jumping from platform to platform. So again, like this guy will be, it's a sort of a side-scrolling game, and he's going to jump from that platform to that platform, and presumably the primary goal of the game is going to be to avoid obstacles. So some classic examples of a platformer would probably be like the original Mario games, Mega Man games. I think a lot of those are platformers. So that's kind of what we're working toward. So what we're going to be doing is creating something like that. Now, what we're going to need to do to begin with, we're going to, each of these things, remember how I was saying this right-hand side of the screen over here is where we would configure things. And what we're going to need to do is tell it that both of these images are sprites. our sprite images. And how we do that is we click on one of them. We're going to click on the ground first. I'm going to change the texture type to sprite. And I know it's a little bit hard to see. Again, I can't change the font size in Unity. It's unfortunate. So we're going to change the texture type to sprite. Now this is pixel art. So what I also need to do is change mesh type to full rect. Don't worry about that. Why that is, I don't entirely know either. To be honest, I Googled it, and this is what it says. So we're going to change it to full rect. That'll let it tile, like repeat, basically. And then the other thing we want to do is we want to set filter mode to point, no filter. And what that will let us do is make it so that it doesn't automatically try to make it scale up by making it blurry. What it's going to do is when it scales it up, it's just going to make the pixels still visible, because this is going to be a very pixely game. If you were using a game where you weren't using lots of pixels, you would probably want to leave this as it is. And again, because it's a pixel game, we're going to set compression to none. That one doesn't matter. We click apply. We're going to do the same thing for our player, except we don't need to set the mesh mode. So we're going to set the type to sprite 2D. We're going to set the mesh type. It can be left as it is. It doesn't need to be changed. We're going to set the filter mode to point. One other thing we need to do for both of these, we need to set the pixels per unit. This is basically going to change the scale of the game, and they both need to be the same if we want the game to be the same size. I want the penguin happens to be a lot smaller than the ground, so what I'm going to do is I'm going to make the penguins 16, I'm going to make the ground 32, and I think that will either make the penguin much bigger or much smaller, so we'll see. So we've gone ahead and configured our sprites. Again, this right-hand side is where we configure things. It's called the inspector. It's where we go to set things up. All of this is just configuration for pixel art games. Don't worry about it. There's nothing super, I need to know exactly what this is about it. I Googled these configurations. If you don't make these changes, your game will still work. It'll just look kind of crappy until you do. And then you can just search for a Unity pixel art game and find tutorials on how to set this all up. So next thing we need to do is we need to actually apply what we want our things to look like to our characters, because right now they're invisible. So what we're going to do is we're going to click on the player, and inside the player we have that player sprite that we made earlier. And what we do when we click on that, you can see it's got this thing that says sprite renderer, and I'm going to click on where it says none. I'm going to click on this little dot right next to it. I'm just going to go ahead and choose our player object, and there our player now shows up on the screen. So we've got a player. Same thing for the ground. So I'm gonna, if it's hidden, what you need to do is you expand out the ground. We don't want to click on the ground itself, which again was an empty object. That's what we created. Instead, we want to click on ground sprite. And same deal. I'm gonna go ahead and choose the ground here. And it looks like changing that scale did work, because we get these two that look okay as well. And I can just go ahead and move things around over in our world editor, which is great. Now, one other problem that we're going to have, let's say we wanted to resize this. Well, that doesn't look great, right? So what we're going to do over in this right-hand side, again, where we configure everything, we're just going to change draw mode to tiled. And tile mode, again, you can configure a whole bunch of things, but we'll leave that as is. And now if I resize this, it more or less looks seamless. There is actually literally a seam. Oh no, that's actually from the Unity editor, so that's okay. I'm going to go ahead and resize this back though, because right now we're going to leave this as a 1x1 block. Cool. So now, if we were to go ahead and run this, it's still not going to do anything, but it is technically a game, right? I don't know where our camera is. There we go. So I can change the scale to scale it up and down. And yeah. One more problem. This is because I actually had to open this existing project because of the bug with Unity on Linux. One more problem you might have is if it still looks blurry, go ahead and edit project settings quality. So again, that's edit project settings quality, and then we're going to set right over here where it says anti-aliasing, make sure that that is disabled, and that will prevent your game from being blurry. Now again, if you're doing a not pixel art game, you can leave all of this as default. Unity assumes we are not doing pixel art. I am doing pixel art because I am not a good artist. You can make this in absolutely anything you want. So we got our thing right over here. we got our main character, we got our ground, and again, inside each of them we have a sprite. So one problem we were having, again, by default, the camera was in a weird place. And we don't have movement yet, but you would see that when we do have movement, the camera would not follow the player. And so if we had a really long level, we wouldn't be able to see it. Now we could manually program the camera, or we could do the easy thing, which is actually just to take our camera, which is listed over here in the in this left-hand pane right over here, and just drag it inside the player. So all we have to do is drag it inside the player. And then the other thing we need to do is over here when we click on the camera, which is now inside the player, we set the position to 0, 0, and -10 is the default Unity one. We can actually do anything as long as it's as long as it is between 0 and -10, and it'll just make it bigger. It'll basically make it get closer to the character as we make it closer to 0. So you can actually see right here, this is the preview, and if I just want this game to be bigger, all I have to do is just change this camera setting. If I set it to 0, it'll be basically behind the player. And if I set it to anything greater than -10, it'll just make the game really tiny. You could technically do it if you wanted to, but I don't know many games where you want them to be that tiny. So again, how do you make the camera work and follow the player? The easiest, absolute easiest way to do is just take it where it's normally right over here and just drag it inside of the player object so it's nested underneath it, just like we did with that player sprite. So they're in this little tree. And then the other thing that we do is we set the position to 0, 0, and in my case I chose -3 for how zoomed out I want it to be. Now the reason that we set this position to 0, 0 is because when you nest something inside of it in Unity, what it does is it sets its position relative to that. So the player can have whatever position we want, and the camera will always be that position plus 0 in the x direction, that position plus 0 in the y direction, and that position -3 in the z direction, which basically means like zoom out a little bit. You're like, give me some more space. You're way up in my face right now. We're saying, get a little bit further back. This is a 2D game, but it's still a 3D game engine in a sense. So when we hit run now, you'll actually see that the camera will actually be in a good place, which is cool. Now, what else are we missing? Well, for one, there is absolutely no movement, which we'll deal with in a second. The second thing that we're missing is there's also basically no gravity, which is going to be a problem because, again, this is like a side-scrolling platformer, so the ability to fall down and jump up is going to be a critical part of our game. And so we're going to want to be able to do that. And luckily, Unity takes a lot of things that would normally be difficult to do, like writing your own physics engine, and it builds them all in. It's all built in. It's really, really easy. And in some regards, if you've ever used an intro-level programming language like Scratch or Snap, most cases, those programming languages actually make it more difficult because they rely on you to implement your own physics engine in a sense, right? They rely on you to implement falling down due to gravity and jumping back up. Unity will do all of that for us, so in some regards it's actually easier. So how are we going to do that? Switch back into only full screen. What we're going to do is we're going to click on our player, not the player sprite, not the main camera inside the player, but we're just going to click on the player itself. And over here in this right-hand side where we change things, we're going to click Add Component. Now, components in Unity are basically things that do things, which I know is very, very vague, but that's what it is. It's basically, they are things that do things, which could mean literally anything, which is great because it means we can do almost everything with these components. We're going to add a component, and Unity's got some built-in ones. What we want to do is we want to go to Physics 2D. Make sure you choose 2D and not 3D. Or it's just called Physics, actually. We want Physics 2D because we're making a 2D game, and if you choose the 3D version, physics are going to get a lot more complicated. And what we want to choose is we want to choose Rigid Body 2D. Rigid Body 2D. It's the one that looks kind of like a caution sign. Again, I know it's a little bit hard to see in mine. If you're having trouble finding it, you can just type rigid, and make sure you choose 2D and not just rigid body. because this is a 2D game and 3D physics is a lot more complicated. You have to deal with things like what are called quaternions for rotation, and there's a lot of issues. And choose rigid body 2D, and that is pretty much it. Now, if we start our game, our character should just immediately start falling. We haven't told it about colliding with the ground yet, so it's going to fall through the ground, but if you watch closely, you'll see that he is technically falling, and then he passes the ground and just continues going forever. So now we've got our character falling. Next thing we need to do is we need to tell it about the collision shapes, basically. We need to tell it that the ground exists, and we need to tell it that our character exists. What we can do for that is we want to add a collider. Now, you can add it to the player itself, and you can add it to the ground itself. But one of the nice things that Unity will do for us is if you add it to the sprite rather than adding it to the player and the ground itself, then it will automatically size it. So that's what we're going to do. We're going to click on the sprite. We're going to click again, add component, because this is something that does something, so it's probably in the components. Everything else is just things that exist. This is where you tell it how your game works. So again, we're going to click on the player sprite. We're going to click add component, physics 2D, and what we're going to choose is box collider 2D. Now there's a whole bunch of them here. It's like buoyancy if you want to have something that's floating. Circles. Circles are actually technically better for player characters because they can move up and down inclines, but like there's going to be some problems with that, so we're not going to deal with it right now. We're going to choose box collider 2D. It's going to be right near the top. And again, a search for box, and you'll find it right there. Box collider 2D. And you can see that by default, it makes the shape the correct shape for our character. It just completely fits it around it. If it wasn't, you could click this button that says Edit Collider and just drag it around. But we're going to go ahead and leave it as is because that is correct. So we've told it that our player character can now collide with things. What's next? Well, we also need to tell it that the ground can collide with things, right? Because our ground also needs to collide with things. So again, we're going to go ahead and choose ground sprite. Not just ground, but ground sprite. You could do it with just ground, but ground sprite will be easier. We're going to choose add component, box collider 2D. Or again, if you're not doing this, it's going to be physics 2D, box collider 2D. And you can see again, it has completely encircled our box, or inscribed our box within this little green thin outline. And one more thing we're going to do that you can only do if you do it on the ground sprite, again, is we're going to choose auto tiling. And it'll get rid of that edit thing. And now if we resize our object, it actually resizes with us. I'm going to, again, go ahead and undo that because I want it to stay at the default. So now that I've added those two colliders, our game has physics. And if I run our game, then immediately it works. Now, we still can't move. There's still no ability to move. I promise you, I'm hitting the arrow keys right now. But our game does work. And if I put this guy really high up here, so I'll just click on player over here on the left-hand side, because I don't want to move anything inside the player. I'll just click on player. And I'll click on this move button, and I'll drag him up here, run the game, and our player falls down. Very exciting. Now, again, could we do this in anything else? Yes, but one of the nice things about Unity is it takes care of all of this for us, which is great. I'm going to go ahead and move him back down closer to the ground. And in fact, I think if I put him slightly inside the ground, when I start up the game, it'll automatically kick him out because he's not allowed to be inside the ground. Yeah, you can see it pushed him back up, which is great. Yeah, someone in the Twitch chat just said, it just works, and it does. And it just works, and many beginner-level programming languages, in air quotes, actually don't. So in some regards, this is easier. Okay, so we get our player object, we get our ground. If we click on the ground, again, I prefer not to resize the sprite. I prefer to resize the ground itself, and the sprite will resize with it. So if I click on the ground itself, and I click on this little icon up here, I can actually resize. Oh, it defaulted me back to resizing the ground sprite. Can I click on just the ground? Will it let me? I gotta click on the resize option. And we can go ahead. Okay, so that is actually not working the way I was thinking it was working. We'll do it this way. It worked earlier, but we'll do it this way. So we'll go ahead and click on this. We'll click on our resize tool, and we can just, nope, still not working. What is going on here? Okay, so we'll click on our ground sprite. I have been able to do this before, but Unity is not behaving the way I was expecting it to now, which is probably a Linux bug again. Click on our rectangle tool and make it a little bit bigger. And now we get a little bit bigger of a ground, and I can make it bigger in this way as well. And when we run it again, we've got our player character, and he'll stand on the ground, and now we got more ground. And I can also, by the way, make it bigger in this direction as well, just so that you can see it a little bit better. Cool. So we get our game. Very exciting, right? Well, it's not a game until you can move around. So what we're going to need to do to move around is we are actually going to need to tell the game how to do that. We're going to need to tell it about movement. Now, this is one of those things where I think that Unity probably could have built this in, but their assumption is that it's not very difficult to do movement compared to how difficult it is to do physics. And so why not just build it ourselves? And we can do that, and then we can customize every aspect of it. So what we're going to do that, we're going to create our own custom component. Now, all of those things that we were talking about, again, those components, add component button, everything is a component pretty much, all of those were built in. We're going to make our own now, and this is where the coding part of it actually comes in. I know we're now 45 minutes or 40 minutes into this workshop, but that's okay. This is where we're going to actually do the coding part, and luckily the coding part in Unity is not very difficult. In this bottom part, the part where we have our ground picture, we have our player picture, and I have this thing that says scenes, which is basically different levels. I'm going to right click, I'm going to click create, and I'm going to click C# script. So again, in this bottom area, right click, create, C# script. And I'm just going to name this player movement. That's what I'm going to name it. Now, for anyone out there who is not using Linux, all you need to do is double click to open this. And it will open a text editor, and you can start editing. That's all you need to do to start editing. For me, because I'm using Linux, I'm going to have to do it in a different text editor. This is solely because of Linux. Tyler, CodeLabs, demo, player movement.cs. Now again, anyone else should just be able to just double click on this and it should open itself. But for me, because I'm using Linux, I have to do it this way. So now we're in this file. If you've seen Java, this probably looks a little bit like Java. If you've seen Python, this might look really weird. There's a lot more words, but it's more or less the same. We have this class, which we're not going to worry about what that is right now, but it's a grouping of behavior. And then we have these methods, functions, defs, whatever you want to call them. That is where we're actually going to put our behavior. So Unity actually has, you can see by default when we're actually, when we're in here, there are these two methods. There's one called start and there's one called update, right? Unity has a few of these. So there are a few of these methods, and basically every single object, when you attach this component to it, these methods will be run at certain times. So there's a few of these, right? We have this void start, right? We have this void start. Now everything inside of here runs once when the game starts. Right? Everything inside of there runs once when the game starts. This marker, I think, writes a little bit better for this. That's what the void start does. Now the other method that you'll see that Unity will create by default is this one that's void update, right? So we have this other one, void update. What does void update do? Well, this is going to run as fast as possible. That means that every single bit of code inside of here will be running maybe 60 times a second, maybe 100 times a second. It's going to run absolutely as fast as it possibly can. One of the implications of this is that you cannot, in update, do anything that's going to be slow. So you can do things like moving the character a tiny bit. You can do things like like, you're in physics, you can do things like checking if they should die because they collided with a bullet. You cannot do things like making a request to a website because it'll be too slow. Not that you would really do that in a game very often, unless you're doing like high scores or something. There are ways to do that, but you would not do it in this update method. This update method, again, when the game starts, every single object in the game is going to call update absolutely as fast as it can, just hundreds and hundreds of times per second. It's just going to run through every line of code in there hundreds and hundreds of times per second. So those are the two that'll give you by default. Again, I'll write those out over here. So we get void start. We got void update. We get another one that's called void fixed update. Now, it does not exist by default in the file that Unity will create. If you take a look back at this, you can see that there is no fixed update. But what it will do is, if we make one that's called this, Unity will run it. And what this is it's the same as update, but it runs at a fixed speed. And I think by default it's 60 times a second. So anything that's physics related, it's usually better to do it in the fixed update. Don't worry about exactly what this is. I know maybe it's a little bit complicated. I just want you to understand that, again, update and fixed update, conceptually, they're running as fast as possible. And so rather than doing something like saying, whenever the player presses a button, do this thing, instead what we're going to be doing is saying every single frame, if the player is pressing a button, move the character a tiny bit. So you get update and fixed update for that. Anything that involves movement should usually go in fixed update because it'll be more repeatable. If there's lag, it will run the method multiple times, basically, or certain things like that. That's not exactly how it works, but it's a good enough intuition. So we get start, update, fixed update. What else do we have? We have a few others. There's one called on, void, on, it's capital O, collision, enter, 2D. There's one called on collision, stay, 2D, on collision, leave, 2D. There's 3D versions of all of these as well, which just don't say 2D at the end, which if you use them, you'll get weird bugs because we're making a 2D game, so don't use them. We're not going to worry about these too much for right now, but these are where you would do things like check if the player character collided with a bullet, and if so, or a spike or something, and if so, then they have to restart the game. We're not going to do them right now, but again, if you just make these methods and they exist in your class that you just created in C#, then these things will not run every 60 times a second. These things will just automatically be called whenever you collide with something, which is nice. So those are our methods. Again, this one is once at the very start. These two are constantly running, and these three only happen at specific times. And specifically, that is this first one and this last one, whenever something starts or stops colliding. And this second one is going to be whenever it is colliding currently. So this one will actually run as fast as possible, but only when it's touching something. So those are our methods. We're going to go back to this screen right over here, and we can start making some methods. So we're gonna make some methods. And again, if you haven't gotten this up, all you need to do is when you right-click, create C# script, give it a name like player movement, and then just double-click it. And for you, if you're using Windows or Mac, that should open it. Okay, so we have our methods that are created by default. You can see, again, it's got these little comments, which is nice. We're going to do something to do with movement. Movement things will be more repeatable if we put them in a fixed update method. So again, all we need to do, Unity already knows about a method called fixed update. It just doesn't create it by default. We're going to create it. So Unity will automatically do it. Again, it'll do it at about, I think, 60 frames a second by default. You can change it if you need to, but you probably don't. Fixed update, I'll put a comment. It's called once per frame at 60 frames per second. So fixed update is where we are going to put our code for the game, for the movement, right? This class again is called player movement. This is where we're going to deal with player movement. So again, remember, fixed update. What does it do? Well, it's called about 60 times a second, and we don't want to do anything long running. It's not event based. What it's doing is it's every 60 seconds we're going to check if the player is pressing a key, and if they are pressing a key, we are going to move the character. That is all we're going to do in here. So how do we check if the player is pressing a key? Well, the way that we'll do that is if input.getKey, and in quotes down, or not down, what do we want to do? We want to move right first, right? So if they're pressing right, that's how we check if a key is down. Now, what if you didn't know that? Well, the simple thing to do is quite simply to Google it. So what I would do is I would Google Unity, check if key pressed. And you find the first result. And, oh, hey, check this out. This is, well, apparently this is a different way to do it. You can do .keycode.left control or something like that. Again, I always want to stress, this is part of being a programmer. It's not knowing everything about Unity. It's about knowing the complicated things about Unity, like the fixed update and update, the way that they work, the way that components work. When it comes down to the nitty-gritty of things, Googling things is absolutely your friend, and real programmers all the time are going to be Googling things. You, to make a more complicated game, are probably going to be Googling things and asking friends and maybe asking us for help in chat.srnd.org. But that is absolutely expected. So right here we've checked if the key is pressed, and what we want to do next is we want to move the object. Now, how do we move an object? The way that we move the object is actually, if I click on our player over here, so I'm going to switch back over here, it's got this rigid body 2D. This rigid body 2D is actually the part of the character that can move. It's the part that deals with physics. Rigid body 2D. There are other ways to move the character, but we want to use the built-in physics engine, because the built-in physics engine will let us do things like add ice physics really easily, because all we need to do is change the material to, you know, ice physics or something like that. It'll let us do things like change how massive our character is. So if we added a power-up that makes them, you know, float in the air, we could do that by just changing their mass to be negative. So we want to use the rigid body 2D. Now, what we're going to do, and we can do this together, so I'm going to go ahead and save this file right here. All we need to do to add our component here is just click on the player, and then click and drag on this player movement C# script, and drag it into this right-hand frame. Or we can just drag it right on top of our player over here. We don't want to do this on player sprite. We want to do it on the player itself, so it should be in the same object as the rigid body. So I'm just going to click and drag, and you can see it says player movement script, and it's added over here. So we have our player movement. Our player movement is in this right-hand pane. It wants to talk to rigid body 2D. It wants to move rigid body 2D around. How do we do that? So again, we double-click to go back into editing this. What we would do is we would need to call this method that's just called getComponent. Right? GetComponent. How do we tell it what type of component we want to get? The way that we tell it what type of component we want to get is in these pointy braces. And what we do there is we type what type of component inside these pointy braces before the parentheses. I'm not going to talk about what this does exactly, what exactly it is that we're doing when we call this getComponent. But more or less what it's doing with these pointy braces is it's telling C# in this weird way that C# supports what type of component we want to get. So we want to get a rigid body 2D. That is the type of component we want. So that's going to be inside these pointy braces, and then after the pointy braces, we're going to put the parenthesis and parenthesis. So now we've got our rigid body. Which again, if we click back on our player, this is the rigid body, right? It's called rigid body 2D. In C# it's called rigid body 2D with no space. What we want to do with our rigid body is we want to move it. How do we move something conceptually? How do we move anything? We add a force to it. So .add force. And then what force do we want to add? Well, we want to add a force that moves to the right, but it does not move up, right? I mean, there's two directions, two conceptual directions. There's four directions really in a 2D game, right? Left and up. And then we have the opposites, right and down. And you can think of right as just negative left and down as just negative up. Now, how do we let's zoom out a little bit so I have a little bit more space to write here. here. That's a little better. How do we add how do we specify what that is? Well, we type new vector2, parenthesis, end parenthesis. Vector2 is going to be a direction. And in fact, if I want to, I can make this a little bit more clear. So let's refactor, right? We'll make a variable called rigid body. We'll just call it body. So rigid body 2D is the type. Body is equal to this. We got a thing that's a vector2 moving right. Get component. Or sorry, it's not get component. It's new vector2. And this is going to be 0. I think, is it left and then up? No. This is going to be our left direction. Our first one is our left direction. If you don't remember, you could always just test. So we'll just pick a number, let's say 10. So we're going to move 10 units and 0 up. And we'll test this out. If it doesn't work, we'll just change the numbers until it does. So we get our moving right vector. And then we'll do body, which is our rigid body, dot add force, capital A, capital F, moving right. We'll save this. Go back in here. It's automatically reloaded. Again, remember we dragged this on earlier, so it should show up under rigid body when we click on player. And now if we run the game, in theory, we'll see if this works in practice. Sometimes a lot of programming is debugging. When we hit right, oh, look at that, we do move right. Now we can't move left yet. We can't jump yet. But conceptually now we understand what to do, right? So if we want to move left, what are we going to do? Well, we're going to, just reverse the right vector, right? By the way, if you imagine the cardinal direction of right, the absolute right is probably a common one. So we can actually refactor this by, instead of calling it moving right, you can actually just type vector2.right and just multiply it by 10 because we want to move 10 steps. Multiplying it by 10, what it's going to do is it's going to multiply each component. Moving right is just 1, 0, so it's going to make it 10, 0, because 10 times 0 is 0 and 10 times 1 is 10. And we can also move this up here because both of these are going to use it. So now what we want to do is we want to do else if input.getKey left body.addForce vector2.left times 10. Or vector2.right times -10, right? I mean, either of those would work. So again, what is going on here, right? It's really important that we conceptually get this. 60 times a second. 60 times a second we're running this code. Every bit of code here is going to run 60 times a second. By default, we can change it. Unless they have changed it. Maybe it's 30 times a second now. I don't know. It's probably 60. It's going to run multiple times a second. And what it's going to do is it's going to, every single time it runs, check if the right key is down. And if so, it's going to add 10 units. Now again, this is the reason why we did it in fixed update rather than update, which tries to run as fast as possible, because update is going to do it as fast as possible, and if there's lag, the player character is not going to move as far, which doesn't really make sense. Or if the computer's running really fast, then the player will move faster, and if you let the player change their frame rate, then they can change how fast they move, and that's not good. We want them to move a specific amount per time. So even though 10, it's some arbitrary number that we've chosen, we can guarantee that as long as we don't change the speed of fixed update, they will always move the same speed. So again, we got left and right now. So when we run our game, give it a second, left and right. Now I'm accelerating pretty slow. This is kind of like ice physics right now. I've kind of got some ice physics things going on. We'll mess around with this at the very end and see if we can fix that a little bit better. But we more or less got our thing. Now what if we want to do jump, right? We can add a separate one. Now I'm not going to put this in an else if because the player can either be moving left else right or right else left. They can't really be moving left and right at the same time. They'd be standing in place. That's why I did an else if. Here I'm just going to make it a separate if statement because they could be jumping and moving at the same time. Input.getKey up body.addForce. Now what do we want to do? Well, we want to do vector2.up. and we're going to multiply this by how much we want them to jump for every single frame that the up key is held down, because right now we're not checking if they are allowed to jump, we're just letting them jump. So if they just hold down the up key, they'll just keep jumping up. But we'll choose 100 just because eventually we'll fix this. You'll see, again, there's some problems with this. So 60 times a second, we're going to check if they're holding right or left, and if they are, we're going to move them right or left. And then 60 times a second after we've done that, we are going to move them up if they're holding down the up key. Now again, one of the nice things about this add force thing is that we have acceleration. So in real life, people don't move immediately. They do speed up and slow down a little bit. Now ours is ice physics, which is terrible. Everyone hates ice physics. But we can fix that by just speeding up the acceleration. We also have jumps. So they'll jump up and they'll fall back down, right? Now again, what is the problem with this? Well, if we hold down up, we'll actually fly up forever. If I zoom out a little bit, so again, I'll click on our player, I'll click on the camera that's attached to him, and I'll just move it a little bit further back, so I'll move it to -7. So we zoomed out a little bit more. We'll rerun it. Right now, if I tap it really quickly, I don't jump very much. If I tap it a lot, I'll jump really high. Again, that's because we're not actually checking if he's touching the ground, which is something that we should probably do. Again, we'll get to that at the end, but more or less we have our player character now. So this is a platformer, so the key part of this game should be jumping, right? How are we going to make it so that people can jump? Well, what we need to do is we need to create another platform, right? Another piece of ground. Now what we could do is right-click, create empty, drag it down here because it nests it in a weird place by default, rename it, add the sprite, all of that stuff, but as I always like to say, programmers are lazy. We don't want to repeat our work for ourselves. So instead what we're going to do is we're going to click on this ground, and we're going to create what we call a prefab. And a prefab is kind of like what it sounds like. It's like a prefabricated piece of things. It's like something that we can just keep reusing. It's kind of analogous to a class, if you're familiar with classes. Again, if you're familiar with classes where you have a class and you can create instances of the class, it's kind of similar. But it is, it's a little bit more complicated, basically. It's like you have to create one of them in the world first. L_E3, we will get to your question in just a sec. Always rigid body 2D unless you're making a 3D game. I want to get to this really quickly, and then we'll take some questions from people who are struggling with any sort of errors, and then we will, and then we'll move on and try to do some cool things before the end of this. So what I'm going to do, to create a prefab, all I do is I click on our ground object, the base ground object, not the one that's inside of it. The base one, click and drag down into this area down here where we keep all of our other stuff. And you'll see it'll make this one that looks like the ground in 3D, which looks really stupid because it's a 2D game. Again, I could even make a player prefab, right? I could click and drag the player down here, and it would create a player prefab. And that's kind of stupid, but it would work. And we'll actually even try it. So if we want to make instances of our prefabs, all I want to do is I just drag them out from this bottom area up here, and it'll create a copy. And I can even drag another player character out here, and they will both move at the same time because they get all of these parts from this right-hand side. They get all of them. So I'll run it, and you can see both of these guys move, both of these guys jump at the same time. They both collide with the ground. I probably held that jump button for way too long. I think I jumped off the edge. Because again, we're gonna have to fix that at some point. Or we run it. Is that gonna work? Yes. Okay, cool. And then, you know, like I can fall off. Oh, by the way, they rotate. So that's something to fix too. And if the first character rotates, it'll actually cause some problems because the camera will rotate with it. We're gonna delete our second player character. It's usually easier to click on things on this left-hand side. So we got our two grounds now. And again, I'll go ahead and run it with just one character now. And we'll test this out. And again, if I walk off the edge, that is incredibly disorienting. Because the camera rotates with the character. The way we'd fix that, by the way, click on your player over here, and right over here in the rigid body 2E, we'll click on constraints and we'll constrain rotation. So if we run it now, our character does not rotate, which is kind of what we expect. We could also constrain his height or other things, which wouldn't really make as much sense, but it's something we could do. Cool. So now we get the basics of the game. I'm going to really quickly go into some questions that we've been getting. So first of all, getting an error for the rigid body thing, it can't add a rigid body object. Remember that when we did this, what we did was we right-click, create empty, right? This should be over here. It shouldn't be nested inside of anything else. So we created an empty. We renamed it. I'm going to rename this player test. Right? And then inside of that, we created a sprite. And we called that, right-click over here. Sprite test. It's really important that we add all of our things to this outer object. The one that we created that was actually originally called an empty, right? Or it was called a game object. It's really important that we add our rigid body to this. So when we add physics 2D, we choose rigid body 2D on here. And it's really important, likewise, that when we add our player movement, we're not adding it to the sprite, we're adding it to the player itself, that outer object. That's one of the most common errors that I see with this sort of thing. If you don't do that, it won't work. The only thing that you should ever really add to the sprite itself or anything underneath it is going to be that collision. Because it's going to collide with the sprite itself more than anything else. It just makes it easier. You can add it to the outer object as well, the collision. Everything else pretty much needs to be added to the outer object unless you have a really good reason for it. So that's one of the most common problems. If basically what happens is, again, in this part where we're calling get component, rigid body 2D, if it's not on the same, again, we have our script right here, which is where we wrote that code. If it's not on the same object as the rigid body 2D, it won't work. If rigid body 2D is inside of a nested object, that'll actually, there's ways to do that, but it's not you have to call it get children components or something like that, I think, which is not what we're doing here. So that was that question. The other question that we had was, is it rigid body 2D or just rigid body? Rigid body is for 3D games. What they should have done is named them rigid body 3D and rigid body 2D. But what happened was Unity did not support 2D games for years. And so everything was just called rigid body because the assumption was it was 3D. Anything to do with physics when you're making a 2D game, choose rigid body 2D, choose box collider 2D, choose physics 2D. Everything should be 2D. Because if you choose 3D, then you have to deal with things like rotation in 3 dimensions, which is much more difficult. And you have to deal with the fact that everything is infinitely thin, so nothing can really collide. There's a lot of problems. And it'll also be a little bit less efficient too. It'll run a little bit more slowly. Cool. Any other questions? Feel free to post them in the chat and we can go through as we get them. But I want to see if we can figure out a few more things really quickly before we're done. So one of the things we want to do is, again, we have this ice physics, it's really bad. Ideally what we'd like to do is kind of have a maximum speed and just have the other thing be our acceleration. And if we get up to the max speed, then we stop. How would we do that in here? Well, first of all, one thing that would be nice is if we could change the acceleration in the same way that we can change things like our mass, right? Where over in this right-hand side, we can just change it. How do we do that? All we need to do is up here inside the class, not inside one of the methods, but inside the class, we make a public. We give it a type. And in this case, this type is going to be an integer. Or you can make a float, which is a number with a decimal place. We'll make it an integer. And we'll call it acceleration. I think I spelled that right. Just call it accel. And we'll give it a default value of 10, which is what it is right now. We'll also make a public int max speed, and we'll make this maybe like 20. So it'll accelerate 10, units per 60th of a second up to a max speed of 20. Now, why did I put these up here? These are just variables, right? Why are they up here? Because if they're up there and if they're public, if we wait a second, if I save and we wait a second over here, Unity, please. There we go. Check this out. They're right here. We can just change them. So we don't have to make code changes anymore. We can actually change them, and we can even change them live while the game is running to test things out, which is cool. So that's the first thing that we're going to do, is we're going to put those things up there so that they show up in the Unity editor. And Unity editor will just deal with it. And this can be anything, by the way. It can be a vector, it can be another object. If you want to, have this thing spawn bullets, you could actually just create public game object, I think is what it's called. Maybe just object, or lowercase object, and I don't remember what it is. You can create another variable. As long as it's public and it's up here, Unity will create a picker where you can pick the other object you want. Or you pick a prefab, I think in that case. So I'm going to get rid of some of these methods we're not using so we can see it all in one place. So what do we want to do now? Well, instead of add force with vector right and vector left, with it being 10, now we're going to do Excel. So now we're adding the acceleration every single time. Oh yeah, it is game object. The reason I was confused is because I don't have the editor, so nothing is being highlighted properly because it doesn't know about any of this stuff. I'm just using my own text editor. If you're using the other ones, it should highlight it, and that's why I was getting confused because it's like, why isn't this highlighting? It is game object. Okay. So what we've done is we multiply it by acceleration. What do we want the next thing to do? Well, we want to check if the speed is greater than our max speed. I think the way we do that is body.transform. I wrote this down somewhere, I think. Did I? I actually didn't. I should have written it down. So body dot, I think it's body dot velocity dot magnitude, which is basically the same thing as saying speed irrespective of direction. Velocity includes the direction, speed does not. The way we get speed is velocity dot magnitude, which, looking at it this way, by the way, if you're really into trigonometry, we have our little object. He's going in a direction, right? He might be jumping and moving at the same time. Velocity is going to be this direction and the speed. The magnitude of the velocity is just the length of the arrow, which you could technically figure out with like trigonometry or whatever else. This is why I was saying don't do 3D games, by the way, because you really do start getting into using trigonometry, and like if you're not really into trigonometry, it's a little bit more pain for your first game. So if the magnitude is greater than max speed, then what we want to do is set the velocity to the velocity, I think it's dot normalized, which basically says make the speed 1 and just tell me the direction. What we're doing is we're basically getting the direction and not how fast it's going, and we'll multiply that by max speed. Right? So again, going into this, what we have, I'll draw this a little bit bigger. Right? We have our object. It's going in a certain direction at a certain speed. What we'll do is we'll normalize that to being between 0 and 1. So every single element is going to be between 0 and 1. So this has got a certain speed in this direction, a certain speed in this direction. Both of these are guaranteed to be below 0 and 1, and the length of this entire thing is guaranteed to be exactly 1. So that's what .normal is doing. So we're converting this into just this, basically, this thing, and then we're multiplying it by our max speed. So we're making it so that the final length of all of these is going to be exactly max speed. That's the way that I'm going to do it. There are other ways to do it. You could just check if the max speed is over a certain one. This is actually going to have a bug too. This is going to have a bug too, but that's okay. It's going to have a bug with jumping because jumping also affects our max speed. There are ways to get around it. We're just going to test this out really fast because we want to just get something working, and again, you can play around with it more. So we'll add some comments. Cap the speed. Speed limit. For any of you who can drive, that is funny. It's not really that funny. Movement, acceleration, I think that's the right spelling, and jumping. Right? So what we did, if the speed is greater than the max speed, then set the velocity to be the current velocity normalized to 1 times the speed. So let's try this out. We have to restart the game, I think. This should prevent some of the ice physics. Yeah, so we can't go infinitely fast. But the nice thing about having these little variables is we can just tune this. So let's say that we want our acceleration to be 40. Oh, check that out. And max speed maybe is too fast, so we'll set this to 10. Still a little bit fast. Let's try like 6. It's not bad. This is what I was saying about the bug. So what's happening right now is actually the player is floating down because when he's flying down towards the Earth, he has an acceleration. And that acceleration is setting his velocity to be greater than max speed. So again, there are some bugs. There are other ways to do this. This is the simplest way that I immediately came up with. I knew that there were going to be bugs. You can figure out other ways around it. Or, coincidentally, I chose a bird in this case, so it actually kind of works out. This entire game actually kind of works out solely because the bird is the main player character. Okay, so we got that basic game. The other thing we could do is we could prevent double jumping. The way that we would do that, I'm not going to rate the entire thing, but what we would do is probably something like this. We would do avoid on collision, stay 2D. What we would do is we would make one of these other special methods that I talked about at the beginning. This one is the one that happens whenever you're in a collision with something else. It takes a parameter that is the other thing you're colliding with. What we could do is say something like this: if other dot tag or dot game object, because other is actually just a collision object, we want to get the thing that it's associated with. Dot tag is equal to ground. Can jump is true, and then we'll also check this void on collision leave 2D. I said I wasn't going to rate the entire thing, but I guess I am going to rate the entire thing because it's not too hard now that I know what I'm doing. Can jump is false. We'll make another variable. This one will be private. Can jump is false. So what will happen is whenever we're touching something, if it's tagged as the ground, we'll set the can jump to true. Otherwise, we'll set the can jump to false. And then we'll check if they can jump before we allow them to jump. The only other thing we need to do now is we'll click on our ground object. We have to stop the game. Whenever we're changing things while the game is running, they won't actually get saved. It only counts if the game is not running and you change things. So what did we end up with? I think we ended up with 20 and 8, or 30 and 8 maybe. Because again, those got changed back whenever we stopped the game. What else we need to do? Ground. Click on this tag. Click add tag. This one was already here because that Unity bug. So what I would do is I would add a tag, call it ground. And then we go back to our ground. Choose the tag ground. What is the error? Oh, private. What is its type? It's a type Boolean. And we'll rerun this. It'll take a sec. And now, in theory, I can only jump once. For some reason, I can only jump 0 times. So live debugging, my guess is it's because I put the box collider on here, so this should also be tagged as ground. Let's see if this works. It's not quite working. But that's okay. Again, I'm not going to troubleshoot the entire thing. Again, this is more or less how we would do jumping. There are some problems with this. As with everything else, with really common problems, if you just Google them, right? If you just search for Unity prevent double jumping or prevent infinite jumping, you can probably come up with good ways that other people have solved the problem. Same thing with capping the max speed. You can probably come up with other ways that people have solved the problem. And that's part of what being a programmer is about, is Googling things and reusing other people's work, because we're all lazy. And as much as possible, if someone else has already done the work for us, do it. And then eventually you'll know it, right? I mean, eventually if you do this enough, you start to remember the answers. And once you start to remember the answers, then it's much easier because you actually, you can just do it from the top of your head. But I haven't used Unity in 2 years, so I don't really remember the right ways to do things. I'm just kind of guessing. There's probably better ones. So again, by the end of this, we now have this very basic game. I have broken jumping, but we had this very basic platformer game. There's no win condition. There's no lose condition. We can fall off the world and go in endlessly. But if we wanted to do all those things, again, we have this this component. This one just does movement. We can add multiple components. We could make another one. And this could be called player death controller. Just player death. Let's call it player death. Right? Drag it onto our player. Compiling. Interesting. Okay, Unity's frozen. We could add, we could edit our player death, and then what would we do? Fixed, update. And we would check if the transform position, that's how we get our position, .y is less than, I don't know, -100. I'm just guessing, right? If that, then, I don't know, some sort of game over. Right? So that way they don't fall infinitely. We do all these things. This is the general format. Again, the important part is not necessarily that you understand absolutely everything about Unity and know every single method and every way to do everything you could possibly want to do in a game, because that's not how programming works. Even if you're a beginner, programming is, going to be like this for the rest of your life. The only difference is that you're going to know how to do the basic things off the top of your head, and you're going to be struggling to do more complicated things. Unless you get a really boring job. I mean, you could just have a really boring job where you know how to do everything every day, but it's a really boring job. You don't want to do that. So that is going to go ahead and do it for us. I'm going to take some questions. If anyone else has any questions about how to do things in Unity, what sort of things you can do, how to do things like VR, if you're interested in anything else, feel free to post them in the Twitch chat right now. While I'm waiting for people to post their questions, I will also mention if you need any help and you're watching the VOD, or you're watching this live but you need help in 20 minutes or 3 days or 3 months, feel free to check out chat.srnd.org. There's a link down in the description below. And again, register for a free account. We have a bunch of people who are happy to answer your questions 24/7, more or less. There's usually someone awake. So we're always happy to help out with any questions you might have. Last workshop of this second week of CodeLabs is going to be getting an internship, and specifically focused on getting an internship if you're not a CS student at a top school. Like if you're not getting a CS degree at MIT right now, how would you get an internship? So that applies to like high school students. It applies to people who have graduated maybe, but haven't graduated, have dropped out of high school. It applies to people who are getting a CS degree, but it's from like a community college, and so like you're having troubles. All sorts of people. How do you get an internship if you're not the sort of traditional group of people that recruiters are looking for? So it's going to be tomorrow at noon Pacific. Definitely tune in for that. And we'll have another lineup of workshops next week that'll be announced on Saturday. Those will be in the chat.srnd.org or in your email if you're part of CodeLabs. Other than that, again, feel free to ask us any questions. The VOD will be up on Twitch for as long as it'll let us, and on YouTube. And hope to see you again at the workshop tomorrow, which I will not actually, you won't see me. It'll be taught by one of our former students, Fedor Paretsky, who is very good at this sort of thing, getting internships. But I will be there, and hope to see you all there. Thanks so much for tuning in.